student going rock climbing inside a volcano. Crazy student, but hey, to each their own. He just heard a rumbling, so he decided to climb out. The student's elevation, which is in meters, as a function of time, is shown below. So they give you guys a table, E for elevation, T for time in seconds. And let me just give you a picture just so we can see it better. Again, we have a little mountain, or a volcano, sorry. Nice little volcano. And we got this crazy student out there inside rock climbing, right? And again, there is a rumbling, so there's a little shaking in the ground. And that's when this kid decides, you know what? I better get out of here. Starts climbing out. So, we have the first question. How deep into the volcano is the student when he decides to leave? First of all, to understand which one is what, we gotta see what is our input and what is our output. So let's look at our table. Once again, letter E is for elevation, and letter T is for the time in seconds. Well, which one is gonna be my input, guys? In this case, I gotta tell you guys, we're gonna go. Time is usually always the input. 99% of the time, the input is always going to be time, and elevation is going to be the output. So when I tell you a certain time, you can tell me where this student was in terms of elevation. So how deep into the volcano is the student when he decides to leave? Well, at time 0 is when he decides to leave, because that's when the rumbling started, and this person wants to get out of there. So the elevation of this student was at negative 24, and we're talking about elevation in meters. Negative 24 meters. Now, why is it negative 24? Why is it negative, you might ask? Because 0 is considered the corner, or the top of the volcano. Once the student reaches here, he's at 0. So it's all about perspective, guys. And in physics, we call it, again, relative to the student, or relative to the viewer, etc. So now for question number 2. At what rate is the student climbing out? When we talk about rate, guys, and you've heard this a lot before, we call that the rate of change. And in math, we always like to call it the rise over the run. And in high school now, we like to call it something else. The change in the y over the change in the x. How much are the y and the x changing? Well, let's look at this, guys. Remember, input is always x, output is always y. And there's a reason why they're flipped. A table usually has the x first. Again, they like to write it however they please. So the faster you know which one's your input and output, the faster you're able to answer this. So let's look at each one. So if this is my input, what are we doing over and over to this graph, or to this table? Well, to get from 0 to 4, we had to add 4, right? To get from 4 to 12, we had to add 8. To get from 12 to 22, we had to add 10. 22 to 28, we had to add 6. And 28 to 32, we had to add, I would say 6 again. Yeah. No, actually add 4, sorry. And now for the output, let's see. From negative 24 to negative 21, well, because the negative is getting smaller, you actually did the opposite. We added a 3, right? And negative 21 minus 15, we added a 6. Negative 15 to negative 7.5. Well, for this one, I'm going to need a calculator. Let's double check what's going on there. Negative 15 negative, minus 7.5. It was actually a plus. So plus 7 because it's actually half. That's right. And 7.5, negative 7.5 minus 3, that would be negative 4.5. So if you add another 4.5, you get this one. And finally here, that's a plus 3 to get to 0. Well, I don't know if you've noticed this, but it looks like we don't have a common or a constant rate of change. However, something easily we could do is you can always pick 2 points and find the average. I would personally choose just the endpoints because they have a zeros and we like zeros. So if we had the point, and let's write it backwards so we can have it x and y's. So my x is 0, my y is negative 24, my x is 32 and my y is 0. Once again, I'm writing them correctly because x is my input and y is my output. To find slope, guys, do you remember the y2 minus y1 over x2 minus x1? We'll just plug them in. Remember, this is your first point, so we're going to call this x1, y1. This is your second one, so we're going to call it x2, y2. So my y2 is 0 minus, my y1 is minus negative 24, and x2 is 32 minus 0. Well, what's a negative times a negative, guys? That's positive 24 over 32 minus 0 is 32. So my slope will be 24 over 32. Could we reduce that, guys? Can I reduce by 4? Maybe. What's 24 divided by 4? That's 6. What's 32 divided by 4? That's 8. And I can reduce one more time by 2. That will be 3 over 4. So what does this mean, guys? This means since my y is on top, remember my y, we're talking about elevation. So it's for every 3 meters, how much time has passed? At the bottom is my x, right? My x is in seconds, right? It's my input. 4 seconds. So if you wanted to, you might see the answer in text. You could also see it for every 3 meters. The student, you could say 4 seconds pass. 4 seconds pass. And that's how you could say it also. So just watch out, guys. Make sure you know which one's your input and your output.